The third portion of this chapter is simplifying the expressions when we've got sum or difference formulas in it. So this is what we did in section 5.1 and 5.2, but now we're adding the a plus b expressions. So we're either going to simplify or we're going to verify the identity. So first of all, using the sum or difference formulas, simplify sine of x plus 3 pi. So really what I've got right here is a is going to be x and b is going to be 3 pi. And I know that 3 pi is going to equal something from the unit circle. So since I'm dealing with sine and we've got plus here, this is the sine of a plus b. So sine of a plus b is the sine of a cosine of b plus cosine of a sine of b. And we'll write out all those pieces. We know a is equal to x. We know b is equal to 3 pi. So cosine of x and then sine of 3 pi. And then we can solve for the cosine of 3 pi and the sine of 3 pi. So sine of x, cosine of 3 pi, that is the same as the cosine of pi on the unit circle. And we know the cosine of pi is -1. The sine of 3 pi is the same as sine of pi on the unit circle, which we know is 0. So this whole back quantity, cosine of x times 0, goes away, and I'm left with sine of x times -1, which is negative sine of x. So simplifying sine of x plus 3 pi is the exact same thing as negative sine of x. Same idea with verifying the identity. This is the type of problem where we've got the equal sign. I'll draw my vertical line down, and then I'll simplify the more complex side to the more simple side. And here the more complex side is going to be the side that's got our a plus b. So the sine of pi plus theta is the sine of a plus b. So sine of a cosine of b plus cosine of a sine of b is my sum formula we're going to use. We know a is pi and b is theta. So the sine of pi, cosine of theta, plus the cosine of pi, sine of theta. Sine of pi, as we said before, is going to be 0 times the cosine of theta. The cosine of pi is -1. So that whole quantity goes away, and I'm left with negative sine of theta. So 8 and 9 were very similar, just two different ways of asking a problem. One is simplifying and one is verifying an identity. Both end up being negative sine. The last one is a little bit more complex in that I've got two identities I'm being multiplied together. Sine of x plus y, sine of x minus y. And I want to simplify that down to cosine squared of y minus cosine squared of x. So the more complex side is definitely going to be this left-hand side. So I'm going to draw my vertical line way over here just so I've got a lot of room to work with. Sine of x plus y and then sine of x minus y. Sine of x plus y is the sine of x, cosine of y, plus cosine of x, sine of y. So this whole area right here is going to be the sine of x plus y. I then need the sine of x minus y, which is going to be the same thing, except for I'm going to have a subtraction sign. So that whole bracket right there is the sine of x minus y. So I'm multiplying sine of x plus y times sine of x minus y. There are my two expressions. Now the very nice thing about the way this is set up is this right here is the exact same expression, just one is plus and one is minus. So that's the format of a plus b, a minus b. And when you FOIL that out, that's a squared minus b squared. So this whole big expression here is going to simplify down to sine squared of x, cosine squared of x, minus cosine squared of x, sine squared of y. I got to be careful here because this is actually a y here that I've got. Sine squared of x, cosine squared of y, minus cosine squared of x, sine squared of y. Now, as I look at this, I ultimately want to end up with cosine squared of y and cosine squared of x, which is what I've got right here. My cosine squared of y minus cosine squared of x. So somehow I've got to get rid of these two sine squared pieces. And the best way to do that is to think Pythagorean identities. So let's use the Pythagorean identities. We know sine squared of x is the exact same thing as 1 minus cosine squared of x. And then sine squared of y is the same thing as 1 minus cosine squared of y. Now if I go and distribute each of these pieces in, the cosine squared of y, distribute that in, cosine squared of y minus cosine squared of x, cosine squared of y. And then in this back piece, I distribute my cosine squared of x in. So I get negative cosine squared of x plus cosine squared x, cosine squared y. Two negatives when I multiply gives me a positive. I can see I get a negative cosine squared x, cosine squared y, and a positive cosine squared x squared y, which go away. So then I'm just left with cosine squared of y minus cosine squared of x, which is what I was trying to prove. So cosine squared of y minus cosine squared of x.